Hello and welcome to SudoKanard. This is again an ascending starter Sudoku puzzle, but this time, it was created by myself. So it's a practice puzzle for the upcoming Sudoku Grand Prix, and I decided to construct a puzzle, and this is what I came up with. So it's really on the difficult side of things. And if you want to try the puzzle before watching the video, the link is in the description. So the special rule is that whenever you have a number in the margin, the number is the sum of the first few digits, and you sum the digits while they are ascending. That's what the title is saying. For example, you could have a 3, a 4, a 5, and an 8. That's 20, and then a smaller digit like a 7. So that is a valid option to fulfill this clue. It would probably not work with the 22, but that's another matter. So this puzzle is difficult, and I only put clues that are very indecisive. By that I mean that there are many options to satisfy this 22 clue with ascending digits. But if you consider this crossing of 20s here, and this 22, you see that it's a very busy place. Namely, so those 3 digits must be ascending, but those 3 digits here must be ascending because you need at least 3 digits to have a sum of 20 or 22. So it means that those 4 digits are ascending actually, which means that this digit must be big, but not that big. So this must also not be that big. So that's at most 9, at most 8, at most 7. So this will never be less than 7. And conversely, this will never be a 1 because we need to be ascending here. This will never be a 2 because we need to be ascending both here and here, and I can't have a 1 in 2 positions. So we know that this is between 3 and 7. But there's also a reason why 3 is impossible here. And this has to do with some well-known secret about Sudoku, which is that the sum of all digits in a row is 45. And you see that the initial sum here of 3 or maybe 4 digits, maybe 5, is 20. The sum on the other side is 22, which makes a total of 42. So outside those 2 sums, you must have a total of 3, which is a single digit 3 or a 1-2 pair. So either digit 3 or digits 1 and 2 are outside those sums. So if I try to put a 3 here, it forces a 1 or a 2 here, and you can't have one of those 2 sets of digits outside the ascending sums. So this is why 3 is no more an option. We can see that 7 doesn't work either, because 7 forces 8 and 9 here, and we don't have any value left for this position. So we can remove 7 as a candidate here. And 6 doesn't work for a similar reason. Here we must have, let's say, 7 or 8, here 8 or 9, and here's something bigger as well. But then how do you achieve this 22? If you try to take 4 digits or more, well, you will have at least 7, 8, and 9 in here, plus this, it's already more than 24. That doesn't work. So this 22 must be the sum of 3 digits. And what happens here? I'm not sure that's the easiest way of proving this, but this is what I'm coming up with at this point. No, actually, this 20 here doesn't work, because if I try to put another digit here, that's already at least 22. So this 20 must be done with 3 digits, but you see that nothing works in this cell to come to a total of 20. It's just not possible. With a 5, we have a maximum of 19. So 6 doesn't work. So we're left with 4 and 5, and actually you will see that 5 doesn't work either. So why is this the case? Well, you need another 15. So how do you do 15? If I try to put just a digit here and a digit there, then the maximum value is 18. So we need at least 3 other digits. Let's say here, so 3 other digits here, so 1 here and 2 there. So what happens? If I try the minimum value, that will be a 6 and a 7. Then what? Well, no, first, this has to be a 6. Because if I try to make this a 7, then this will have to be 8, and we will have more than 20. So this has to be a 6, and the same logic applies here. So we need another 6, and 6 is repeated in the box. So that doesn't work. And this is finally a 4. So that's quite the expensive entry ticket to the puzzle. So this is 4. What can we deduce from that? Well, this must be from 1 to 3, and this must be from 1, 2, and 3. And then you see that the maximum here is 7, so we need at least 2 other digits. And actually, 3 digits won't work. You see that this is more than 20. So we need exactly 2 other digits. So this sum ends here. Something else we can see is that we have at least 3 digits here and at least 3 digits here for the 22. So the missing digits, be it a 1 and a 2 or a single 3, must lie here. And if it's a 1 and a 2, they must be in consecutive cells like this or in those cells. But you must see that this 20 prevents this case from happening. Because if I do this, then this digit will be bigger than that, and the ascending sum will only be this digit. So that doesn't work. And the missing digit is actually a 3, which means that this is 1 or 2, and the other 1 or 2 in the row must be taken in the sum, so it's here. And then we must add 21 or 22, which requires at least 3 digits. That's not a 3. And likewise, here we must have at least 3 digits. And I already said that we had to take those 2 digits exactly. So that's a 3 with 1 or 2. So this is 5 or 6. We need another 14 or 16. And there are not that many ways of achieving this. 14 could be a 5 with a 9. Could be a 6 with an 8. And 15 could be 6 with 9 or 7 with an 8. And you see that this has to be 8 or 9, and the other 8 or 9 will be the biggest digit in the 22 sum, so it must appear here. And that's interesting regarding this 22, because now we know that 22 needs at least 3 digits, but could it be done with 4 digits? With 4 digits, knowing that this has a maximum of 7, the maximum values here will be 6, 5 and a 3 because 4 is not available, and you can see that this is 21, so that doesn't work. So 4 digits won't work. This 22 will be done with 3 digits. And if you are used to Kakuro or Kira Sudoku, you know that 22 in 3 digits can only be 589 or 679. So this is a 9, this is 5 or 6, this is 7 or 8. Now this 20 needs exactly 2 more cells by the same argument as here. So this is between 5 and 7, so we need another 15, 14, or 13, which will be achieved only with 2 digits. So this has to be 8 or 9. And if you look closely, you see that 20 can only be achieved with the smallest values, with 1, 4, 7, and 8. So that's the only way of achieving this. And this is massive for what comes next. Here we have 16, so this is a 6, this is now a 5, that's a 2, we have here 11, so that's a 9, that's an 8, and that's a 1, and here this is ascending. You can check that this is 22 indeed. And take a 2 in here. So that's 20, and 22 must be ascending on the other side, and we can see by the same argument as this row that the outies, the digits not in the sums, they have to sum to 3 without using 1, so it's a single 3 here, and the rest of the digits are ascending to 6, to 5, 6, and 9. That's 22, all right. This is ascending, so we must have a 1 in here. 1 and 2, so once again, 3 is out of the sums. We need another 19, so that's at least 3 digits. And here we have at least 3 digits, so the missing 3 is here. And where do we look? Perhaps here we have 3 and 8 missing. What about this 20? We have 5, we need another 15. 15 could be done with 2 digits, but it would be 6 and 9, or 7 here and 8 there, but 6 and 7 are both unavailable. So we need 3 digits to make 15, and you can see that the only way is to have 4, 5, and 6. And the ascending streak must stop here, so this is a 1, and we have a 7, 8, 9 triple in here. Now this 19, if we try to achieve this with only 2 more digits, they must sum to 16, which means there are 7 and 9, but this is not possible. So we need at least 3 digits. But now what are the maximum values of 3 digits? With 4, 5, and 6, well, that doesn't work because 6 is not available, so let's say 4, 5, and 7, and ta-da! That's 19. So those digits must be 4, 5, and 7. To be honest, I tried to put a 20 here and an 8. Oh no, I didn't try. There's an 8 here, so... No, I did not actually. 5 and 7, they're not here, so they must be here. Here I need a 1 somewhere. It's here, and that's a 6. Here we need 2, 3, and 8. Here we need 4, 5, and 9. And as you may guess, the latter part of the soul, it's much simpler than the beginning. Here we need a 2 and a 9. Let's move on to this 21, I think. 21 needs at least 3 digits. And the interesting part is that without using the 5, the 6, or this, it could still be achieved with 4, 8, and 9. But then this 20 is impossible. Because if we have 21 here and 20 there, then those 3 digits must sum to 4, which will never happen. So these digits must be smaller than 5. And you see that 1 is not available, so the only way is to have this. That's 14, so this is 7. And this is smaller than 7, and actually just by Sudoku this is a 1. And that's 8 and that's 9. So 4 is not here, so 4 is there, and here we have 3 and 7. That's 7, we need another 15, 7 and 8 won't work, that's 6 and 9. And this digit here is a 2. 3, 4, and 8. That's not 8, that's not 3. Here 20 is the sum of those 3 digits in ascending order. Let's do some cleaning. That's not 8. That's not 4. That's not 3. And that's not 2. The digits here are 1, 6, and 9. And at this point we still have this 20. If we try to make 20 with only 3 digits, you see that it's not possible. The maximum values here are, has a maximum of 6. So you see that this will never be enough for 20. And actually, whatever digits we put in here, this completes the ascending trend. So we need another 13 with 3 digits. So this has a maximum value of 3 and a minimum value of 3. So that's a minimum of 4, that's a minimum of 5. And the minimum value here is 19, so we must add exactly 1, and the only way to add 1 is to add 1 here. So that's a 6, that's a 4, that's a 3, and the rest now should be plain Sudoku. So this 3 makes this 8, 2, and 3. Up there, that's not a 4, so 4 in this box is in here. 1 9 pair here, so that's a 6. Here we need 7 and 9. 3 and 4, so that's 8. That's 4, that's 3. Here we need a 2 somewhere, it's here. And a 5. So what do we need? Well, this 8 resolves this. And it's been sitting there for quite a while, I think. Here we have 1 and 6. Here we have 7 and 4. This 7 resolves that. Here we have 1 and 2. It resolves that. And finally a 5 and an 8, and that's it. So a pretty difficult puzzle. This I will definitely not deny. So the key point was really finding that this digit only has one option, and finding about this leftover 3, I think. And then there were quite a few key points in the puzzle, but something spectacular in this variant, I should say, is that in many places we see that only one option remains, and it places a handful of, I should say, a mouthful of digits just in one move. That's really a weird variant, I must say. But it was quite fun to set this puzzle. Thanks for watching this video, and see you soon on SudoKanard.